All right, we are now ready for lesson 3.5, and the topic, as you can see, is symmetry. The word symmetry you can think of as the word sameness. Let me just write that up there. The word sameness. And what we mean by that is there are three different types of symmetry that we're going to be talking about today. Line, point, and rotational. And after looking at that symmetry, what should happen is we should create sameness. We should create either a mirrored image. The wording in our standard is we are going to be describing rotations and reflections that carry an image onto itself. So mapping an image onto itself, creating the same image or a mirrored reflection of that image across a line. So it kind of gives you a preview of where we're headed today. So let's go ahead and jump into some specific examples like you'll be doing on your homework. Okay, so here you can see those three types of symmetry that I was referring to in the introduction to this lesson. And just to kind of illustrate them, first of all, let's talk about line symmetry, and you've got a description here of what line symmetry is all about. What we're looking at here is if we can draw a particular line, it could be vertical, it could be horizontal, it could be diagonal, any way that a line can be drawn to create what is called a mirrored image. So let me illustrate what I'm talking about here. You can probably notice that if I draw a vertical line and pretend like that's straight, that is a straight line that's going right down from the vertex of that all the way through the triangle. So with line symmetry, you can think like this. You can either use your actual paper to fold, but a lot of times you can just use your imagination. What if you did fold on that red line? And what you want to know is, do these two sides, if you folded on the red line, would they match up? Would they meet when this object is folded? And if the answer is yes, then we have line symmetry. And that would be the case in this particular figure, this triangle. We would definitely have line symmetry. Now, as long as you have one line that creates sameness, this mirrored image, now it's got to be exactly the same on either side of the line, whether that's vertical, as in this case, or horizontal. If you have a line anywhere that accomplishes that, then you've got line symmetry. Okay? Now let's talk about point symmetry. So with point symmetry, there will be a center point, okay? So some point right in the middle that you would actually spin this around or turn it, the word rotate, as we've talked about before, 180 degrees. So basically, that's, if we went all the way around, if we made a circle, that's 360 degrees. Obviously, any shape is going to end up back in its original position if we turn it a full 360. So for point symmetry, what we want to know is, what if we turn it 180 degrees? Okay, if we just go half a turn, do we end up with this same original figure? And if the answer is yes, then we've got point symmetry. So it's got to be a 180 degree rotation. And after that rotation, you ask yourself, do we end up in the original figure shape? And sometimes you can apply this. It looks the same upside down. That would be, and sometimes you can just actually turn your paper upside down and see if the same shape exists. And that might be a good way for you to determine point symmetry. With rotational symmetry, we're going to rotate less than 360. So point symmetry is always an exact 180 degrees, okay? Always 180. So with rotational symmetry, it would be something less than 360. For example, if we just rotated this figure 90 degrees, then it would still be this same figure, and so that would be an example of rotational symmetry. So we'll just go ahead and establish this. Since it is a rotation of less than 360 degrees, that means if you do have a figure that has point symmetry, it has to have rotational symmetry, because 180 degrees obviously is less than 360. However, just because it has rotational symmetry doesn't mean it's going to have point symmetry. For point, it's very specific. It's got to be exactly 180 degree rotation to get back to itself. But rotational can be any degree less than 360 rotation, and you basically map the original figure onto itself. Okay? So I'll just do a couple. I'm going to jump to another slide here just by way of illustration. This figure that I'm looking at right here, let's just test for line symmetry. So for line symmetry, I should be able to draw a vertical, horizontal, sum line, and that would be the case. If I draw a vertical line, assuming that I'm right in the middle, I could create line symmetry. I could create sameness if I folded on that blue line. And again, I'm probably not right in the middle, but it is possible to take a line that is right in the middle of this figure, fold on it, and the two sides would match up. Okay, that would also be true if I drew a horizontal line. Okay, it doesn't have to be both, but as long as it's accomplished with one of those, then you've got, or any line, then you've got line symmetry. Okay, so let's talk about point symmetry. So there's a center point around which I can rotate this figure. All right, so we'll just say that's the center. And this would be an example of a 180 degree turn. All right, I just turned 180 and I've got the original figure again, okay? So that would also have, not only does it have line symmetry, but it also has rotational symmetry. Okay, so I'll just go back to the original position. And if it has point symmetry, then it also has to have rotational symmetry. So that's going to be accomplished. I mean, I could turn, 90 degrees, and I don't have the original shape if I turn 90, but obviously we've already proven that we would if it's 180, and since 180 is less than 360, then I've got, not only do I have point symmetry, but I will also have rotational. So this particular shape has line, point, and rotational symmetry. Okay, so by contrast, let's just take a look at this. If I draw a vertical line here, vertical, I don't have sameness. These two sides would not match up if I folded on the blue line. I'll just do a horizontal. Let me erase my blue line. You probably can tell that that's also going to be true if I do a horizontal line. I'm not going to have sameness with either of those lines. Can't do a diagonal line anywhere. If I test for point symmetry, then that's a 180 degree turn, and a 180 degree turn does not map the original image to itself. So that cannot have point symmetry. And there is no degree measurement that I could rotate on. That would be 90 degrees. That's not the original figure. 180, 270. None of those get me back to the original figure. So this particular shape would have no symmetry. Okay, so just a way of illustration. Let's get back to your homework examples. And then hopefully after seeing there's several of these, we'll work through together, and hopefully this will make sense to you. Not a difficult concept. All right, so we're just going to go through each of these examples, and we're going to check off all that apply for each shape. So determine if these have line, point, and or rotational. Some of them may not have any. All right, check all that apply. All right, so we looked at something like this already. It definitely has line, okay? If we rotate around a center point 180 degrees, that's what it takes for point symmetry, we end up mapping the original figure. We're back to the original figure, so it does have point symmetry. And as we looked at a minute ago, if it has point, then it's got to have rotational. Okay, but it doesn't necessarily have to have, if it's rotational, it doesn't have to be point. All right, just like we talked about a minute ago. Okay, so for number 2, this definitely has line symmetry. I can draw a vertical line, and if we fold on that line, these two sides would match up together, so definitely has line symmetry. And then we could also rotate. It doesn't have point symmetry because that would mean it would be upside down. It would look like this if I rotated 180 degrees, so it doesn't have point symmetry. But it does have rotational symmetry because if I rotate, say, 90 degrees, erase my drawings here, a 90-degree turn would basically move this vertex up to here, okay? And we would be back, using the language of symmetry, we would be mapping the image onto itself after we did a 90-degree rotation. So in this particular case, it has line and rotational symmetry. All right, so for number 3, we try to draw any kind of line to create symmetry, but if I draw a vertical line and fold on it, the two sides don't match. That would also be true if I draw a horizontal line, they're not going to match. So this particular shape does not have line symmetry. So let's see if other symmetry exists. Point symmetry would mean there's a center point. I do a 180-degree turn, and I end up mapping this original, I'm back to this original shape. And that would definitely be true. If you can imagine just flipping this figure over, turning it 180 degrees, these two sides, or these two bottom sides, would actually just change places. So point symmetry exists. And again, if point symmetry exists, then it's automatic that rotational symmetry also has to exist. Okay, so for number 4, looking at a way to draw a line somehow and create sameness, fold on the line, the two sides on either sides of the line don't match up with a vertical line. That's also true for a horizontal line. So line symmetry doesn't exist here. Doing a rotation of 180 degrees would basically just make this upside down, so it would look something like that. That's not the original, so it doesn't have point symmetry. And then rotational symmetry, if we do any kind of rotation less than 360, can we map the original figure to itself? And there's no way to do that. I mean, when we get to 360, we are back to the original, but it's got to be a degree less than 360. So this one basically has no symmetry. All right, so let's jump down to number 5. Testing for line symmetry. Looks like we have line symmetry. If I draw a vertical line, then I would have sameness. If I fold it on the red line, then I'm going to have the same thing. They're going to match up. All right, so line symmetry definitely exists. Erase my line. Okay, let's see about point symmetry. So for point symmetry, you're basically going to flip this. If you flip this over, turn it so that it's upside down, it almost, you would think maybe it would be, but the top, notice this would become the top, and it's got that V shape, and this would become the bottom, which would be a point like that, so the V shape would actually be opening up. And so you can always kind of get an idea, look at the top and the bottom, and if they're different, then when you turn 180 degrees rotation, then you're going to have this on the top, and it's not going to match on the bottom. So we do not have point symmetry. But rotational symmetry exists because I could turn this, a 90-degree turn would basically move this vertex up to the top, or any degree measurement less than 360, I could turn, and it would put this vertex up in this position. So as long as it's anything less than 360, then it's got rotational symmetry. So there is a way to map this figure onto itself with a degree measurement less than 360. So number 5 would have line and rotational. All right, number 6, let's test line symmetry. So I draw a vertical line, that doesn't work. I draw a horizontal line, that's not going to match up. So no line symmetry here. What about point symmetry? So if you turn this 180 degrees, then basically these two are going to trade places. And so we definitely do have point symmetry here. And if you've got point, then you've got rotational. So that would be your answer for number 6. All right, so for number 7, testing for line symmetry, I'm going to draw a straight up and down vertical line, and that creates sameness. I've got a mirrored image on either side of that red line. So definitely we have line symmetry. Point symmetry would result in this really just becoming an upside down A, so that's not the same. Don't have point symmetry. And there's no way to rotate in any degree less than 360 in a manner that would map this figure onto itself, create the original. So the only symmetry we have in number 7 is line. All right, so for number 8, testing for line symmetry, can't get there with a vertical line. Doesn't happen with a horizontal line. There are no diagonal lines that would create sameness, mirrored image. So line symmetry definitely doesn't exist. If I rotate 180 degrees, which is the point symmetry test, just think about this flipped over, upside down. This point is going to come up here, and this one's going to go down here. So that's not the original shape. So point symmetry doesn't exist, and there is no degree measure that I could rotate around less than 360 that would map the figure to itself. So for number 8, it has no symmetry that exists. All right, let's take a look at number 9. So for number 9, testing for line symmetry with a horizontal line, that doesn't create symmetry. A vertical line, that doesn't. If I fold on either one of those, the two sides are not going to match up. So I don't have line symmetry. Now for point symmetry, kind of a good indicator for point is from the center. There's always a center point that we can rotate around. You'll notice that you basically have these opposite, they're not really opposite, across from each other diagonally from the center. And that's true. You got a matching pair of points over here. So basically when you turn 180 degrees, I'll call this 1 and this 2, just to kind of give you an idea. Then 1 and 2 are going to trade places, okay, with a 180 degree turn. It's like we just turn it halfway around. So we definitely have point symmetry. And then again, if point symmetry exists, then so does rotational. So that would be your answer for number 9. Number 10, if I draw a vertical line, it would basically split this up into 2 equal parts. That's also true if I draw a horizontal line. So I don't have to have both, but this shape, number 10, definitely has line symmetry. I can fold on either one of those and the 2 sides of the line would match up. Okay, and for point symmetry, let's see if there's a point in the middle. that I could turn, and the top and the bottom would basically trade places, and it maps the original image back to itself. So point symmetry exists. And again, if point symmetry exists, then so does rotational. All right, number 12, number 11, sorry. Looking for line symmetry, you can probably see that that doesn't exist with a vertical line. Doesn't exist either with a horizontal line. So we're going to throw out line symmetry for number 11. Point symmetry, basically this flips over and it becomes an upside down R. So obviously that doesn't map to itself. And with rotational, just trying to turn any degree measure less than 360 to see if it gets back to this original shape. Well, it would get back at 360, but it's got to be less than 360. So number 11 would be none. Number 12, I could draw a vertical line right down through these two vertices, and I would create sameness on either side. I could also, well, I was going to say we could do that horizontally, but that's not the case. So there is a vertical line that creates symmetry. We do have line symmetry. And at first glance, I thought that was basically a symmetrical shape, but it's actually not. So let's see, point symmetry would mean that these two would trade places. So this, if you think of this as the smaller half, would actually become on top, and then this bigger part would be on the bottom. That's not the original image, so point symmetry doesn't exist. And then for rotational, there's no way to rotate any smaller degree measures less than 360 and map this figure to itself. So the only symmetry that exists for number 12 is line. All right, and then for number 13, let's see, can we draw a vertical line right down the middle and create two equal halves where if we folded on the red line, these two halves would match up? And yeah, it looks like we can. So 13 would have line symmetry. For rotational symmetry, I'll just erase my line here. We're going to basically flip this over, and these two then would be on the top, and this would be on the bottom. Kind of rough sketch, but obviously rotating 180 degrees is not going to map this original figure. It's not going to create the original. So we don't have point symmetry. However, if we just turned, say, 90 degrees or some degree less than 360, then, for example, I could turn so that this little leaf, if you want to call it, when I turn it, it just comes up here, and then they all just replace each other. So we are back to the original image. So this particular case, number 13, would have rotational symmetry along with line symmetry. Okay, 14, we'll test for line symmetry. Not possible with a vertical line. Vertical line does not create a fold over which we could make these two sides match, and that would also be true with a horizontal line. Point symmetry, let's see, can I rotate around a center point and create the same image? And looks like you can. So when I turn this 180 degrees, the top and the bottom just trade places, and we're back to the original image. And again, I know I've said this a lot, but if it's point, then it's got to also be rotational. All right, number 15. Let's check for line symmetry. So if we do a vertical line, for example, and fold on it, the two sides would match up. So that's definitely how we determine line symmetry. Point symmetry, if I turn around a center point 180 degrees, these two top shapes would trade places with the bottom. and we're back to the original shape. So that's called mapping an image to itself. So we definitely have point symmetry. And then, of course, then we also must have rotational symmetry. Okay, so 16, with a vertical line, I can't fold on a vertical line and make these two sides match up. And that's also not possible with a horizontal line. If I folded on a horizontal line, these two, the top and the bottom parts of the line, sides of the line would not match up. So it doesn't have line symmetry. Point symmetry, if I turn this 180 degrees, just basically flip it over, do we have the same image? And yeah, we do. And then that means we also have rotational symmetry. For number 17, vertical line, there are no vertical lines I could draw to create the same side, same equal side on either side of the vertical line. That's also true for a horizontal line. So line symmetry doesn't exist. Point symmetry, if we flip this over, it's not going to be the same shape. You can kind of tell this little part is going to be over here, and then it's going to kind of do like that. So not the same shape, not the greatest artist, but I think you can tell using your imagination that we're not going to get the same shape if we turn that 180 degrees around or flip it over. And then I think that's also obvious that we cannot accomplish getting the same shape mapped to itself by any degree measurement rotation less than 360. So number 17 would actually have no symmetry. All right, 18. Can't accomplish line symmetry with a vertical line, but it is possible with a horizontal line. If I draw a line like this and fold on that red line, then these two sides would match up as we fold. Okay, so we definitely have line symmetry. For point symmetry, if I turn this 180 degrees, it's basically just going to open up in the other direction. So that's not the same thing. And then rotational symmetry, there's no way to turn it incrementally less than 360 degrees and map this original figure to itself. So number 18 would only have line symmetry. All right, almost through. Number 19, let's see if we have line symmetry. So can we draw a vertical line and create the same thing on, if we folded, those two would not match up, the two sides. And horizontal line, that's also true. We can't match up the two sides in either case. And that would, you could also, in some cases, you can have a diagonal line, a slant line, but wouldn't help. There are no lines that create sameness. So let's think about point symmetry for number 19. So if I rotate 180 degrees, then these two would go on top and this would come down to the bottom. That's not the same original shape. So point symmetry does not exist. However, if we just move a smaller degree measure, say 90 degrees or something less than 180, there is a way to turn this a degree measure less than 360 and cause this little piece to come up here and they all just replace each other. So I could turn this a degree measure less than 360 and cause these separate three pieces to basically replace each other, and that would mean that this one just has rotational symmetry. And then finally, number 20, we could accomplish symmetry with this vertical line. If we folded on that line, the two sides would match up. And it looks like that would also be true with horizontal, but again, it just takes one. So we definitely have line symmetry. If we rotate around a middle point, sorry about that, I pressed too hard. We rotate around a middle center point, 360 degrees, then these two and these two are just going to trade places, and that creates symmetry. We can rotate 180 degrees, so since it does have point symmetry, then it also has rotational. Okay, so I hope that helps. That's all the examples. You'll be doing some of that in your assignment. So I hope that prepares you well for the homework, and if you have any questions at all, feel free to reach out to me.